So today, my lecture is on linear equations in two variables, and these are two different forms that my linear equations can take. Now, a linear equation is the simplest model that we will be using, and essentially it's called linear because it's the graph of these are what are straight lines. So these are the nicest ones to graph. Right? So this particular equation, right, if I plugged in 0 for x, so if I plug in 0 for x, then I get out b. And so a point that has 0 for its x coordinate and b is just a number, this is what we call the y-intercept. So that leaves m essentially to represent what we call the slope, which is really a descriptor of the steepness of the graph. So m is the slope, which represents the steepness of a graph. So because m is the slope and b is the y-intercept, we call this form of the graph slope-intercept form. Okay? This is also a linear equation. It's just in a different form. I can manipulate it into this form, essentially by solving this equation for y, but this is what we call the general form. Now, one form is really not better than the other. It just depends upon what you're doing with it. So slope-intercept form is very nice for when I go to graph things because it already gives me, it's a really easy point to find, the 0b, and then it's easy to graph my equation using the slope. But sometimes we like the general form too, it just depends upon what we're doing with it. But these are both equations of straight lines, and it's very nice if you can recognize them because it's easy to deal with them. So if I'm graphing, then all I need to do is plot 2 points if I know that it's a straight line. Okay, so if I want to use my slope-intercept form here, I want to find out what the slope and the y-intercept is of this graph. Now this particular equation is in what we call general form, right? It's this same form that I have up here. But in order to see the slope and the y-intercept, what I first need to do is essentially solve for y. So I'm going to take my 3x plus 4y equals 6 and solve for y. So my y is here, so I first move everything that does not have a y in to the other side, so I'm going to subtract 3x. So I have 4y is equal to 6 minus 3x. So now the last thing I need to do is isolate y, so I divide both sides by 4, and I end up with y is equal to this 6 minus 3x over 4. Now I can break this apart. When I have one thing in the denominator, I can write both of these things separately. So I can write y is equal to 6 over 4 minus 3 over 4x. Now my order is slightly different here, right? But my slope-intercept form up here says y equals mx plus b. So if I write it in a different order, just to put it in that same order, and 6 over 4, I could divide the 6 and the 4 both by 2 and get 3 over 2. So this is my equation in slope-intercept form. So now this is telling me, right, my slope was the number in front of x. Here my slope, I'm just going to call it m, is negative 3/4, and my y-intercept is the point 0, 3/2 because of this here. Or I could have said 6/4, right? It basically 1.5 is a decimal. All right, so again, let's do the same thing for this one. Now this one, I already have actually slope-intercept form. So this one is very straightforward. I can just sort of see it, but I have to make sure that I am in fact solved for y, and I am, right? I have y equals essentially mx minus b in this particular case. So my m in this case is 3, and my y-intercept is the point 0, negative 1, right? If I plugged in 0, it's very quick to check. If I plug in 0 for x, this term turns into 0 and I'm left with negative 1. This is my y-intercept. Y-intercepts always have 0 as an x coordinate. All right. So let's use a different one. So I have y equals 2x minus 1. Okay, so I'm just going to draw a quick sketch of, we've already kind of touched on graphing, but once I recognize this as a straight line, it's very easy for me to just plot 2 points. Basically, I usually plot a third one just to make sure that my calculations are right, but obviously I always put in 0, -1, so because that's the easiest thing to find is to plug in 0 and get out your y-intercept. So I have this point right here, which is 0, -1. I should label my axes here. All right, so if I plug in 1 just to plot another point, then I get 2 times 1, which is 2, minus 1, so I get 1, 1. So I have 1 and 1 up here. And then just to make sure that I really am on a straight line path, and because I know I should be, I get 2 times 2, which is 4, minus 1, which is 3, and so I have 2 and 3 here. Okay? So this is the graph. So one of the things that is usually troubling when we try to draw graphs using this point plotting method is sometimes if we don't draw enough points, we don't get a complete sketch of the graph. But if I know that this is linear, I know it's a straight line, it's very easy to just plot a couple points and graph them. All right, so let's look at what is the slope, okay? So essentially, I've just got a line here, okay? So this is the point 0b, if I'm thinking that this is my equation, y equals mx plus b, all right? So this is the graph of just some random, any value of a linear function, and when I plug in 0, I get out b. So I'm just assuming, I'm just choosing this random point here, I'm calling my y-intercept here is 0b, okay? So the slope, the way that we calculate slope, so I just have 2 points on my line. So this one I'm just calling x1, y1 because that's basically my first point. This one I'm calling x2, y2. So this is just some xy and another point xy on this line. I'm just calling them with subscripts so that we distinguish them from each other because they're not the same point. So essentially my right, this is the horizontal distance. And so this distance, if I were to calculate it, right, it's basically, I would think of, so if I think about this down here, right, this would be my x1 and this would be my x2. And so this distance right here is actually this x2 minus x1. Imagine if I put in numbers here. If this were x is 4, right, and this were x is 2, then this distance would be 2 because I'd subtract 4 minus 2. And so this is just any two numbers would be x2 minus x1. And so the change in x is what we call it, is x2 minus x1. So sometimes we call this delta x. It just means the change in x, okay? So this distance here, right, this is the vertical distance. Right, and if I think about the y coordinates over here, right, it would be like I have, here's my y2 and here's my y1. And so the distance between these two values, right, it's just any 2 points, would be the top value minus the bottom value. So that's my change in y, my vertical distance, is equal to y2 minus y1. So slope is defined by, right, basically delta y over delta x. So it's the vertical distance. Usually we call it, like, we usually say rise over run. So the vertical distance is the rise of my graph, how much it's rising. And then my horizontal distance is what we call the run. So the dog runs back and forth in the yard, straight across, right? So it's rise over run, delta y over delta x, which I have these defined up here. Delta y is y2 minus y1 over x2 minus x1. So this is our common formula for slope. Okay, Now, the order that I wrote these in, right, the distance between these two points could also be, I chose this way because it looks like my distance will be positive. But the subtraction of my slope, right, it doesn't matter if I would have written, I could also write my delta y over delta x as y1 minus y2 over x1 minus x2. The order that I write, that I do the subtraction in, doesn't matter as long as I'm consistent. You notice here I started with the y coordinate number 2 first, and I start with the x coordinate number 2 first. Here I'm starting with y1, so I start with x1 on the bottom. The only thing I can't do is to switch them and start with y1 here and x2 here, because then I'll get the wrong sign. So let's just use this formula here and just calculate the slope of a line containing these 2 points. Okay. So we'll call just this one x1 and this one y1. This will be x2 and y2. I could have written them a different way. So if I use my y2 minus y1, so that means I'm going to have on top my m is y2, which is 1, minus y1, which is 3. Then on the bottom I have x2, which is negative 2, minus x1, which is 1. So I have 1 minus 3 and negative 2 minus 1. All right, so I want to simplify then. This is 1 minus 2 is negative 2, and then I have negative 2 minus 1, which is negative 3. So I end up with a slope of positive 2/3, because a negative divided by a negative gives me a positive value. So I have a slope of 2/3. Now if I'd tried to do it in the opposite way, so just to prove my point here, so instead of doing y2 first, let's do y1 first. So I'm going to just do the subtraction in the opposite order. So on top I'm going to do this one, I'll use y1 minus y2, x1 minus x2. This one I used y2 minus y1, x2 minus x1. So if I use y1 first, then this gives me 3 minus 1 on top, this minus this, and then my x's will be 1 minus negative 2. So this one I get 3 minus 1, which is 2, and then 1 minus negative 2 is actually 1 plus 2, so I get 2/3. So you see, it doesn't matter what order I choose to do them in as long as I'm consistent. So if I start with the y from this, then I start with the x from this on the bottom. Okay. Let's do one more slope, or actually just a couple more. So again, just to remind me, I can write my slope here. Oops, I guess I got to keep them consistent here. Just to remind me, this is my slope equation. So if I wanted to choose, so let me choose, I'll just label them because this is the way they present themselves to me. So y2 is 3, y1 is 3, x2 is 4, and then x1 is 2. So I end up with 3 minus 3, which is 0 over 2. This means my slope is 0. All right, this is a special kind of line. That's why I put this in here. If I wanted to plot these points, then I would have the point 2, 3 here, and also 4, 3 here. So a line with 0 slope is horizontal, right? If I connect these 2 points with a line, it's going to be flat. Right? So this equation of this line is basically, when I have this, it just means that y will always be 3. So this is an equation of a horizontal line. So this one, when I have 0 slope, my m just disappears because it's 0, right? Okay, so let's look at another one. I'm going to use my same slope equation, so I'll just call this one x1, y1, x2, y2. So my change in y on top is 7 minus 6, and then my change in x on the bottom is 1 minus 1. Uh-oh, this time I get 1 divided by 0. This is what we call undefined slope, right? We've discussed that division by zero is completely undefined. And so this is something that we are not allowed to do. And so this type of undefined slope is actually, let's just draw a picture here so we can get a better understanding of what this looks like. So I have basically the point 1,6, and I also have the point 1,7, which is right above it. And so this, if I connect my two lines, or my 2 points I should say, then I have a vertical line. So every point on this line has an x-coordinate of x equals 1, and so that is the equation of this particular line. So vertical lines have undefined slope, and they are usually x equals, not usually, they are x equals, okay? All right, so we have looked at linear equations, we've calculated slope, we've looked at some graphs. So now it's actually time for us to write our own linear equations. So when we're writing a linear equation, so we're going to come up with our own y equals mx plus b, then we are going to either, in order to do that, we need a slope, the slope, and 1 point, or 2 points, because we can calculate our own slope. Okay, so first of all, let's think about point slope. We have a new form of a linear equation, and it is called point slope form. Now this is a really nice equation. I know that some students really get stuck on y equals mx plus b, but I would ask you to try and use this because it's actually quite nice. So point slope form actually comes from using the slope formula, and that is if I'm going to use the point xy, so I'm just going to use any xy, and then this other point x1, y1. So using my slope, then I'm going to just have, I'm going to choose this one first. So I have y minus y1, that's this y minus this y, over x minus x1, so this x, this one. So if I multiply across this x minus x1, right, then I'm going to get x minus x1 times the quantity m, right, equals y minus y1. And so the way that we usually write, this is called the point slope form of an equation. And usually we start out with y just because we usually do that. So I have y minus y1 equals m times x minus x1. It's the same exact equation as this. I've just changed the order in which I'm writing it. Right? So I've moved this to this side, and then I changed, because this is multiplication, I can do it in any order. So this is what we call the point slope form of an equation. Now when we're writing equations of lines, this is a really nice one because this is my x, this is my y, and then I can just pop in the other values. I put my slope in here, and then I put my two other, my x and my y coordinate in here. And so this is a really nice, easy form to use. So let's just look at, for instance, let's use this to write the equation of a line that has a slope of, we'll just say 2, and it passes through the point 1, 3. Okay? So that means this x and this y that I've boxed, the points never go there. So essentially this is m, and then this one is what we think of as x1, y1. So I can literally pop things into this equation and use y minus y1 is 3 is equal to 2, because that's my m, times x minus 1. This is a linear equation. It's just now if I could solve it for y and put it in slope-intercept form, but really for most of my intents and purposes, then I can just leave it like this. This is called point slope. So if you get used to using this, then you don't have to worry about simplifying or combining like terms or anything like this, okay? So this is appropriate. It's perfectly fine to leave your linear equation looking like this. All right. Let me use a different slope here because so what if I want to write an equation of a line with slope 1/2 and passing through 1/6. So again, I'm just going to use my point slope equation. So I'm going to rewrite this here just so that we have it. And it really is simple. I can use y minus the y-coordinate 6 equals the slope 1/2 times x minus 1. That's my equation. All right, so what happens if I don't have the slope to begin with? So what if I want to write an equation of a line passing through, I just am given 2 points? Well, I know that, right, I still have this at my disposal. And so, but what I can do now, because I have 2 points, I can calculate my own slope. So let's do that first. So here I have m is equal to, so I'm just going to choose them in this order. I'm going to do the subtraction from, basically, I'm going to write 1 and 2 underneath here. So I'm going to go to 1 to 2. So y's go on top, 6 minus -4 on top of, so my x's are -1 minus 3. All right, so on top I really have 6 plus 4, which is 10, and then I have -1 minus 3, which is -4. So I can simplify this to -10 fourths, or because these are both even, if I divide the top and bottom by 2, I get -5 over 2. So this is my slope. So now I have, right, so I'm going to leave this spot blank here, but I do have this number. I'm just going to leave those blank. Really, at this point, I have 2 different, right? It's going to pass through both of these points. So I have my choice of points. Sometimes it's obvious which one I want to use because it's just easier. Like if they were both positive, I would probably use that one, or if there was a 0, I would use that point. But really, I can choose either one of these and I should get the exact same thing. If I simplify them down to y equals mx plus b, and I put it in slope-intercept form, it doesn't matter which point I use, I will get the same equation. But I don't have to actually simplify them. I'm just going to drop my points in here. So I'm just going to pick this first one just because it's first. So I have y minus 6, and then this will be x plus 1, because when I subtract 1, when I subtract -1, I get +1. And I can just leave my equation just like this. Now, if I really want to, I can solve for y, but that involves distributing this 1 times -5/2 and then combining some fractions at the end. So I would recommend that you get comfortable with this particular method, because we are going to use writing equations over and over and over. Maybe not right now, but in chapter 3, we're going to do it all the time. All right, so just a couple more terms that I want to talk about really quickly are parallel lines. And so that is 2 lines that never intersect. Basically, if we're talking about 2 distinct non-vertical lines, they're parallel if and only if they have the same slope. So for instance, if I had them in slope-intercept form, and I had y equals 2x plus 4 and y equals 2x minus 4, right? 2 distinct lines. They have the same slope here, but they have 2 different y-intercepts. This one has a +4, this one has a -4. These 2 lines will never cross. They are parallel because they have the exact same slope. And then perpendicular lines are 2 lines, just for the record, right? Parallel lines look like this visually, right? They look like they won't cross. Now my lines aren't perfect there, but they should look like they go on. And they don't have this particular slope, but they're somewhere oriented where they just side by side, right? Okay, so perpendicular lines are 2 lines that intersect with 90 degrees. And so that makes them, right, we usually indicate them with this little line here, like the x and y axis are perpendicular to each other. Now they don't have to be they don't have to be like this, right? They could be like this in the plane too. So they don't have to be perfectly up and down across. It's just that this angle between them is 90 degrees. And you can tell if 2 lines are perpendicular to each other if their slopes are negative reciprocals of each other. So that means that one slope is the negative reciprocal of the other slope. So for instance, if I had y equals 2x plus 4, and I had y equals the reciprocal of 2 is 1/2, and then it's negative x minus 2. These 2 lines would be perpendicular because their slopes are negative reciprocals of each other. So for instance, if I had a slope of 3/2 and I wanted a slope that was perpendicular to it, a perpendicular slope, so this is just my shorthand writing of perpendicular because I don't want to write over and over perpendicular. It's got way too many letters in it. Then my perpendicular slope would be 2/3 and it would be negative. All right, I will see you in class.